Saxon Algebra 1, lesson 86. This is a good lesson. This is one that creeps up again and again, kind of like an ill-fitting pair of shoes. I know, that's not a very exciting way to lead in a lesson. What I'm saying is, we're not gonna wear these shoes very often, and when we do put them on, they're gonna pinch a little bit because we haven't worn them in a long time, but they're not bad shoes and we'll wear them and it'll be okay. All right, so what I'm saying is we're not gonna do that, we're not gonna do a whole lot of this in the future, but it will come back again and again, and it will probably annoy you and you'll have to remember these rules. So, hang in there, let's see what we can do. Dividing polynomials is old school. And what I mean by that is we're gonna use the rules of long division that you learned a long time ago. I don't know, 4th grade, something like that. I'll remind you of what they are. The first thing we do is estimate. We try to figure out how many times the outside number goes into the inside number. That to me, I think is the hardest part. Then, once we have a guess, we actually multiply. Right? We write the number underneath. We're gonna do all this. I'm just reminding you of the steps. The third step is we subtract. That's easy. And the fourth one is bring down. That's usually easy, but sometimes it's a little weird. Now, this is called, this series of steps, anytime you have a series of steps like this is called an algorithm. I spelled it wrong. Algorithm. And all that word means is that it is a series of repeated steps. Because as you well know, once we get to the bottom, we have to start all over again, right? With estimating, bringing down, blah, blah, blah. Okay, so what we're gonna do is we're gonna apply this to a problem. These are familiar rules. We're gonna apply them to something that looks really freakish, all right? Let's take a look. Here is our problem. Whoops, it's 86, not 66. That's an 8, I know. 1, 2, 3, 4, 5. Ooh, we have 6 problems in this lesson. 86.1. It says, I'm going to show you how it looks, just so you know. Divide that by x. Okay, now this is easy because look, we're dividing this by a single variable. Well, that's pretty easy. All we have to do is, I'm just gonna write it over again, 3x cubed plus 7x squared minus x. We just divide every term by x, right? And we would get 3x squared plus 7x, right? It cancels out one of them, minus, and then that would be 1. X over x equals 1, right? Okay, that's pretty easy to do. Let's look at a way we could format that slightly differently. This time, I'm gonna take 3x to the third plus 7x squared minus x. I'm gonna put it in a division box. Now that seems weird. We haven't seen division boxes in new problems in a long time. But here's the way we can approach this. And this is important because this is the way we're going to be doing this for these other problems. We ask ourselves, what do I have to multiply to make this number turn into that number? What times x would give me 3x cubed? Well, I'd need to multiply it by 3, and then I'd need 2 more x's, wouldn't I? Because then I'd have 1, 2, 3. All right, there's my estimate. Now I multiply. Yep, I get 3x cubed. Now I subtract. I'm going to put parentheses around here for a reason that will become apparent later. That cancels, and now I can bring down 7x squared. Same thing, we estimate. What do I have to multiply times this to get that? This is way easier than when we have big crazy numbers, right? 7x, then when I multiply, I'll get 7x squared. I'll subtract this, that goes away, and then I'll bring down the next piece, won't I? Minus x. What do I have to multiply times x to get minus x? Oh, I just need the minus sign, so I can multiply by minus 1. Minus 1 times x is minus x, and when I subtract it, look what happens. When I subtract it, those two go positive, and so this comes out to 0. Look at my answer. It's exactly the same as the one I had before, doing it the way that seems obvious. So what we have learned is that this works. It looks harder, and that's because it is, than this way, but when we switch this up and start working with something more complicated than a single variable, we're going to need this approach. So both work if you have a single variable, but when we have more complicated expressions, this isn't going to work. Okay, so this is our new friend. Come, let's see what happens next. Um, 86.2 is kind of a rehash of the other one. Whoops, 86.2. We're going to do it the harder way. Well, the division box way. 12x to the 12th. Okay. We're going to divide it by 4x to the 4th. Oh, that's supposed to be an exponent. It's too big, it's hanging down. Now, because this is a single term, it's not a single variable, but like last time, but it's a single term, right? There's no addition or subtraction, it's just one nice little clump. We could divide and do it that way, but we're going to practice this division box method and see what we would get. What do we have to multiply by this to get that? Well, to turn a 4 into a 12, we better multiply it by 3. Here we have x to the 4th, we need x to the 12th. That means we need 8 more x's. Let's multiply and see if it works. 12 x to the 12th, yes it does. We subtract, beautiful, it cancels. We bring down. Estimate, I'm gonna write these out again because we're gonna want them. This is our algorithm, right? Puffy cloud of knowledge. Okay, so now we bring down minus 8x to the 8th. Okay, to turn the 4 into a negative 8, oh, I ran out of space. Well, we'll just squeeze it. Minus 2, and then x 4th to becomes x 8th. That means we need x to the 4th more. We multiply, we get minus 8. And then we get x to the 8. We add them, right? That's our product rule. We're subtracting this. These two go together to make a plus. It all cancels. Hallelujah, our subtraction is done. Now we bring down plus 4x to the 6th. What do we multiply by 4 to get 4? 1, so we don't have to write anything. X to the 4th becoming x to the 6th plus x squared. We multiply, we get 4x to the 6th, we subtract, it goes away. Our final answer is 3x to the 8th minus 2x to the 4th plus x squared. That is our final answer. I'm just double checking it, sorry. I got sidetracked by something John was talking about. That's the right answer. Again, we could have easily done this problem the usual way where we just divide each one because there's no plus or minus in there, but we're practicing getting used to those 4 steps again. 86.3. Now it's gonna get real. You ready? This time, John invites us to consider this problem. Divide, now he writes all this out, minus he's throwing us curveballs all over the place here. We're supposed to divide that by minus 3 plus x. Now, I think John's being particularly nasty in this example because, first of all, we've got a plus sign in what we're dividing by, and that changes the ball game completely. But he's also given us a mess here. Look how out of order all this is. So the first thing we're gonna do is we're gonna write this in a division box, but we're gonna clean up the order of everything. So here's our division box. I'm giving myself room to write the answer. This is what goes inside of it, but let's put it in order. 3x cubed minus 2x squared plus 5x plus 50. This goes over here, but again, I want the x to be first. I want this in the right order. You don't have to write it down the wrong way. When you're doing your homework, write it down the right way, but be ready for his little tricks. Here we want the x first. This we want in descending order of the exponents on the variables. All right, now, this is gonna be a little bit trickier because here's what we have to do. When we're estimating, we're gonna ignore this. Okay, we're only gonna pay attention to the x. Let me write, I'm gonna write shorthand, estimate, multiply, subtract, and bring down. Look, I abbreviated all those others, but I wrote 4 out long. So the question we ask ourselves is, what do we multiply by x to get 3x cubed? That is the question. What do we multiply times this to get that? 3x squared, right? That's easy. Don't pay any attention to that minus 3. Now, when we multiply, we do pay attention to it. Look what happens. First, we multiply this by this, and sure enough, we get 3x cubed, and then we get minus 9x squared. Now look at how those two match. They're x squareds. The numbers are different, obviously, but these are both squared. Oh, John's worked this out so that it's gonna kind of all sort itself out. So we ignore this part when we're estimating, but we do multiply it out. Now we subtract. Now's when these parentheses become vitally important. This minus turns this into a minus. It cancels against that. Goodbye. This minus turns this into a plus. It's very important that we change it and then circle it. What the circle tells us is this is the changed version. So you never have to wonder, oh, did I change it or did I not change it? Change it and then circle it, and now you know you're done. Now we have to finish our subtraction by combining these two. We call it, this is the subtracting part. Now we're just putting those two numbers together, and it's gonna be what? Plus 7x squared. Oh, fun. We go back to this part. We ignore this when we're estimating, right? We're back up at the top of our list. What do we multiply by x to get 7x squared? Okay, well that would be plus 7x. Now we multiply, and we do pay attention to this. 7x times x is 7x squared. 7x times minus 3 is minus 21x. And look, oh, I didn't bring down. Oh, interesting, right? Okay, so then we subtract. Remember the parentheses. This cancels. This turns this into a plus, and I circle it to show, yeah, that's the final sign. Plus 5 plus 21 gives me 26x. And now I bring down my 50. All right, back to the top, we're estimating. We ignore the minus 3, we just pay attention to the x, and we just look at the first term. I don't think I've said that out loud, but we're only looking at one term at a time, and it's whichever one is first. X needs to be multiplied by 26 to get 26x, so I'm gonna write plus 26. 26 times x is 26x. Yeah, that looks good. Oh dear, 26 times minus 3. 18, 6, 78. And it's minus 78. Put parentheses around it and subtract. Gotta have the parentheses or your signs will get all manner of screwed up. This is minus, this is positive, yay. This minus turns this into a plus. I circle it, and I get 128. Okay, back up to the top of our algorithm again. What can we multiply by x to get 128? Nothing. That's not going to work. X cannot be turned into 128. So this becomes our remainder. Remember old school remainders in learning how to divide? We can write it as part of our answer though, just like we learned how to do that in different ways in our early years. What we do is we write plus, this is the numerator, 128, over this, x minus 3. And that is our final answer. And guess what? It's correct as well. Oh, wow. That's kind of a lot, isn't it? That's what I mean when I say we're going to do these problems, we're going to practice them, but we're not going to use them often. So when we come back to them, most students are like, what? I sort of remember, but I sort of don't. We'll see them again. You'll get a chance. Maybe you'll learn to love them. 86.4. All right. John once again gives us a big fat mess. So I'm going to draw my division box, and then remember that it says divide A by B. A, the first number goes in the box. The number that we're dividing by, quote unquote, goes out here. So he's given me a mess, so I'm gonna straighten it up as I copy it for you. Watch out for his tricks. Okay, there is no plain number term in this one. Oh yes, there is, plus 4. Glad I double checked. Okay, and then we're dividing it by, and again, he has this scrambled up. We always want the x to be first. We do not want the number first because we want the x here for our estimating purposes. Remember, we're gonna ignore that. So I think it's really helpful. Last time I puffy cloud of knowledge the first one. We're gonna estimate with this number only, right? 1, estimate. 2, multiply. 3, subtract. 4, I'm not going to write it out this time. Bring down. BD. Okay, what do we multiply times x to get 2x cubed? 2x squared. Now we multiply. That's 2x to the third. This becomes minus 4x squared. Look, it's lining up beautifully, just the way we want it. We subtract. This cancels. This turns this into a positive. I circle it. Minus x squared plus 4x squared is 3x squared. Beautiful. Estimating x. To get that, I need plus 3x, right? Because there's 1x and then there's 1 here, so that'll give me 3x squared. Beautiful. Now I'm ready to actually do that. 3x squared. That becomes minus 6x, and I glance up to make sure, oh yeah, that's going to be fine. Oh, I forgot to bring down. It's okay if you forget to bring down. You can bring it down when you need it. Parentheses around the whole thing. This is the part everybody messes up. Parentheses around the whole thing and a minus sign out here. If you do not put those parentheses on there, you will mess up the sign on this part of it. That cancels. You should be writing this exactly the way that I do. I want to see you crossing out and bringing down and changing the sign and circling. Do it exactly like I do. Trust me, there's a method to my madness. Please, I can save you drama, I promise. 5x. Let's bring down the 4. X, to get 5x, we're going to multiply it by positive 5. There's the 5x. And this becomes minus 10, doesn't it? Parentheses, subtraction, goodbye, you turn positive, 14. X, to get 14, not going to work, so this is our remainder. I'm just going to use a shorthand of R. And so we write that, we put a plus sign, and then we put the remainder over this. That is our final answer. Let me just double check. 2x squared plus 3x plus 5. Yes, beautiful. Sort of fun? Sort of fun. Sort of fun. Okay, ready? 2 more. Divide. Okay. Again, John has it scrambled up and out of order, so I'm going to draw our division box for us, and I'm going to fix it as I write it down. 3x cubed. Wait a minute. Something's wrong. There's no x squared term. We have a minus 2x, and we have a plus 5. So look what I've done. I notice there's a missing term here. I'm going to leave a blank space there. All right? There's something messed up. We'll fix it later. But I'm going to leave a space because I know we're missing an x squared term. And that's the way John wrote the problem. I'm not making a mistake. That's how he did it. He also messed this up yet again. He wrote it as minus 3 plus x. Always fix this side so that the x is first, because that's what we use when we estimate. Put a circle or a puffy cloud around this so you remember to do that. All right, we're going to proceed without that term there and just ignore it, all right? We estimate. What do we multiply by x to get 3x cubed? 3x squared. That's our estimating. Now we multiply 3x cubed. This will be minus 9x squared. Oh, this is where we want our x squared to be. Minus 9x squared. This cancels. This turns into a plus. Now I'm going to reveal the secret to you. When we don't have a term in the flow of things, what we do is we can add it with a 0 in front of it. What? How cool is that? We can just fill in that empty space in our sequence with a 0. Now that you know the secret, in the future you can just put it right in, right? So now we have something to add to our 9x squared. It doesn't change the value of it, it just gives us a column, a placeholder, right? Let's bring down our 2x. We're ready to start again. Estimate. What do we multiply times x to get 9x squared? Well, that would be 9x, wouldn't it? 9x times x, yep. This should always work out to be the same value when you do this first multiplication. Because if it doesn't, then you estimated wrong. And then this becomes minus 27x, right? Minus 3 times 9. All right, we are subtracting this. Put the parentheses on it. That cancels. That turns this into a plus. And this becomes 25x. And I'll bring down that little 5. Whew, we're getting close to the end. What do we multiply by x to get 25x? 25. That becomes 25x. Good. And this becomes minus 75. Parentheses, minus sign, cancels. This becomes a plus. This is also a plus. So we get an 80 right there. And And so for our final answer, this is our remainder because x doesn't go into 80. So we have plus 80 over x minus 3. This is our answer. And this, I want to write a little note about this now. If you're missing any terms in the sequence, you can add them, just like we did here, using a 0 coefficient. I put the line through it just to remind you I mean the numeral and not the letter O. Okay? So we can do it for any missing pieces in the middle. John always puts them in the middle, so you don't have to worry about them being at the front end. If you're missing anything in the middle, go ahead and use a 0 to add them in. And do we get to do that next time? Yeah, we do. All right, one last problem. And one last time, I'm going to write this down for you to make sure you have it in your notes. And I'll put a few here. Our first step is to estimate. And remember that we use the x only. Then we multiply. And we use x minus 3, for example, right? But we include this part. Then we subtract. And my hint there is use parentheses and then bring down. There's no hints for that. That's easy. All right, so this is everything we've learned about each step in order to make this as painless as possible. Here comes our last problem. And did John give it to us in a scrambled mess? Yes. He tells us to divide -4 plus x to the third by -3 plus x. He's really rough on us the way he writes these problems out. They're hard. So this is the number that goes inside the box, and we can see it's missing multiple pieces. X to the third. We don't have a squared and we don't have a plain x, so we're going to add them. And then -4 comes at the end. And here, this is out of order 2. Always we put that x first, all right? Do not fall for his wicked tricks in the way he writes these problems. It's very annoying to me. Okay, we're going to estimate using just the x. X into x to the third. Well, that's x squared. Now we multiply both parts. That might be a better way to say this. Both parts. That's a puffy cloud in a puffy cloud. Whoa. Okay, now we multiply x to the third minus 3x squared. There's the x squared term we need. We subtract with our parentheses. This cancels out. That becomes plus. And we get 3x squared. And then I'm going to bring down my 0x. X into 3x squared, well, that would be plus 3x, right? Multiply, yep, 3x squared minus 9x. Subtract, that cancels, that turns positive. 9x minus 4. What do we multiply by x to get 9x? Well, that's 9. and we get 9x minus 27. We subtract it with parentheses. This cancels, that goes positive, and we get 23. Running out of paper down here. So then we go back up to where we've been writing our answer, and we write plus 23 over x minus 3. If this was a negative number, then this would be minus right there. How'd we do? I'm checking. X squared plus 3x plus 9 plus 23. Yay, it's the right answer. Okay, so now you know if there are gaps in the variable sequence, you can add them in, just use a 0 in front of them. So they become like placeholders, right? Woo! That's a workout, right? If you weren't feeling smart when you began this lesson, I sure hope you're feeling smart now. Because if you survive that at all, you're doing great. All right, dividing polynomials is now a part of your life. Thank you, goodbye.